Is that Jack? Where? All the way down there?
Kids crossing.
Oh! Ah, I hate that noise so much. This is the worst one.
Hey, you go the fastest.
All in the name
Right,
of
Chip.
science. Why, hello there. My name is Menchville, and you may be wondering what was that you just saw. Well, I'll tell you what that was. That is the Doppler effect, which was created by Austrian physicist Christian Doppler. Now, what it is exactly is a perceived shift in the frequency resulting from a change in pitch. Now, when the car was moving toward the observer with the camera, which in this case was John, the frequency became less than what the frequency was at the beginning or at the end of the track. That results in a shift in pitch, which makes the sound appear louder when you have the car move toward you, and the sound intensity decreases as you move away from the car.
So pretty much what Melvin's trying to say is that the sound waves in the front of the car are closer together than they are in the back of the car, which creates a change in pitch as the car moves by.
Hello there again. What you see right here is a mirror. Now, you all might be knowing that this is a mirror already. You sit and stand in it every day in the morning, looking at yourself in the mirror, thinking you're all pretty and stuff. No offense there, but let's talk to the physics now. Now, what you see and what I'm going to explain in latent terms is that the angle of incidence when the light rays strike the mirror is the same as when it bounces off, or what I would say the angle of reflection. That law states that the angle of incidence equals the angle of reflection. Okay, right here is what you call the crest, and this would be the trough, and then the distance from the median to the crest or trough is called the amplitude, and the distance from one crest or trough to another crest or trough is called a wavelength.
Okay, this is the concave lens. With the concave lens, if one is nearsighted, the lens in the eye causes the focus to be behind the retina. And the lens focuses in front of the retina because the actual eyeball is too long from front to back. To correct this nearsightedness, the person would wear glasses or contacts with concave lenses. And also, the concave lens, it makes light rays diverge and it makes real images.
Go.
This is the prism. It refracts light and the color spectrum. And an example of this could be like a water droplet or like a rainbow. You know.
No.
You can maybe get a nice look at it, maybe. Here's the camera.
Ooh, that's good.
Okay, this right here is a spoon, which is also an example of a concave and convex mirrors, because on this side is the convex side and this side is the concave. If you look really far enough from the convex side, you'll see your image reversed, inverted.
This is a longitude wave, The compressions are areas of high pressure, and refractions are areas of low pressure, like right here. And the wavelength is the distance from the compression / refractions to another one. Example from here to here of the compressions. And here is a diagram of a transverse wave. Got the crest at the top, got a trough at the bottom, and the amplitude is the distance from the crest or trough to the equilibrium position. Example from here to here. And the frequency is how often particles in a medium vibrate when a wave passes through the medium. Constructive interference is when two crests meet to form a new additive wave. And destructive interference is when a crest and a trough meet. The resultant wave is the difference in amplitudes.
Electromagnetic spectrum. So you're sitting in the classroom and you're wondering why. Just what is that spectrum? Listen fine, listen tight, cause I'm about to run it by your cranium. Radio wave, microwaves, infrared radiation, talking about the visible light, heating up when the UV rays with your X-rays in plain sight, gamma rays burst in the Milky Way. Radio wave be transmitting from satellite to your phone, and the microwave be heating up your food, while infrared shows your photos in a whole new light. Like I said, radio wave, microwaves, infrared radiation, appreciating visible light, UV sterilization, yeah, X-ray skeleton with the group, gamma rays mixed with radiation. X-rays don't stop here now, you got to beat with the sunlight. Gamma rays treating that cancer, that's what I'm talking about, hell yeah. Radio wave, microwaves, infrared radiation, talking about the visible light, heating up with UV rays with your X-ray in plain sight, gamma rays burst in the Milky Way, that's what we're talking about.